Unit 7, we're going to look at how to solve polynomial equations. So first thing we're going to look at is solving polynomial equations using factoring. So we're going to use factoring techniques that we learned in Unit 5. So factoring techniques such as difference of two perfect squares, quadratic factoring, sum and difference of perfect cubes, GCF factoring. And then we're going to get into equations that are not factorable. So we'll learn a couple different methods. One of them being something called completing the square, quadratic formula. Then we'll get into higher order polynomial equations, and we'll be using, well, that synthetic division that'll come back, and we'll be using some theorems to help us find all of the solutions to higher order polynomial equations. So in this first lesson, we're going to focus on just factoring techniques. So any equation that can be put in the form ax squared plus bx plus c equals 0 is called a quadratic equation. A, b, and c are just numbers, and a cannot be equal to 0. And this equation is in standard form. So if you ever have an equation with an x squared, you need to set it equal to 0 first before you can factor, so that it's in its quadratic form, and then we're going to be able to factor it, and that'll help us solve. So first set of examples here are going to be using quadratic equations, and when we solve quadratic equations, we're going to be using the zero product property. And basically what that says is if you take any two numbers and you multiply them and they equal 0, that means one of those numbers has to be equal to 0. So think about it. If I asked you, well, what number times 2 will give me 0? It has to be 0. The only way that you can ever multiply two numbers and get 0 is if one of those numbers is 0. If both numbers are 0, that'll still multiply to give you 0. So either way, anytime you need to multiply to get 0, you have to have one of the numbers being 0. So that's actually going to be a helpful property that's going to help us solve these equations by factoring. So the first thing you're always going to want to do when factoring is set the equation equal to 0. That's always your first step. And whenever you see something with an x squared, so you see a variable with an x squared in there, or a variable with an exponent of 2, that means you're going to have to factor. So before you solved linear equations, meaning the highest power was 1 on the exponent, and you set x equal to the number and you get x by itself. But whenever you have an exponent of 2, this means that you need to factor to solve. So you set equal to 0 and then you factor, and that'll allow you to solve. Also, because there's an exponent of 2, this means that there's going to be two solutions. So whenever you have a degree 2 where the highest exponent is 2, this means there's going to be two solutions. So that tells you to factor and that there's going to be two solutions. So those exponents tell you a lot. So we're going to go ahead and we're going to factor this. So we're going to look for numbers that add to -2 and multiply to -24. So I know I'm going to have two sets of parentheses because I'm using quadratic factoring. And I split up the x squared, so x times x. I'm going to have opposite signs because I'm multiplying to a -24. And I'm trying to get -2, which means the bigger number is going to have to be negative. So -6 and 4 are going to work. They'll multiply to -24, but add to -2. And now we're going to use this property, this zero property. Since I have x plus 4 times x minus 6, that means that one of these pieces has to equal 0 in order for this equation to equal 0. So what that allows me to do is it allows me to split it and set each piece equal to 0. So when you do that, you just solve each of these individual equations. So x equals -4, or if I add 6 to both sides over here, I get x equals 6. So that means in order for this equation to actually equal 0, you would either have to plug in -4 or 6, or both. So both of them we keep as solutions. So looking at the next example here, we have a quadratic again. So I have an exponent of 2. That means I'm going to have two solutions. And this also means that you're going to need to factor. So first thing you're going to do is you're going to set this equal to 0. So I have 100x squared minus 300x equals 0. We always have to get it equal to 0 so that we can use that zero product property. So if it's equal to 0, it allows you to factor on the left-hand side and then have your left-hand side written as a product so that you can set each piece equal to 0. Now when you look at this factoring, we don't have a constant term at the end. I don't have a c value. So this doesn't have, it's not that standard form of a quadratic equation, ax squared plus bx plus c. C is 0. So you could either put 0 in there for c or just look for a GCF. So GCF here, I have 100 that I could take out of both terms. I also could take an x out of both terms. So you always want to look for a GCF. Even in the other example, I scanned it first to look for a GCF. You always want to make sure that you're looking for a GCF first, factor that out or divide it out, and then do either quadratic factoring, meaning what numbers add to the middle term, multiply to the last term, or sometimes you can't do quadratic factoring. This example too, if I wanted to do quadratic factoring, I could only factor out the 100, and then I would leave it as x squared minus 3x, and then I'd have to put plus 0. So I'm going to have x left minus 3 equals 0. And then now again I have two pieces being multiplied to equal 0, so that means one of these pieces has to equal 0. So set them equal, so I divide everything by 100, I get x equals 0, or add 3 to both sides over here, and I get x equals 3. So my two solutions, x equals 0 or x equals 3. The next example here, I have two things being multiplied to equal 4. Now, the most common mistake that I've seen with this example is that because you already have the factors, you'll want to just, I've seen people just want to set each piece equal to 4, and that's not the property. The only time that you can set each piece equal to a number is if it's already equal to 0. So this must be equal to 0. You have to set your equation equal to 0. So I'm going to go ahead and I'm going to have x minus 2, x plus 1 minus 4 equals 0. You can't be tempted to set each piece equal to 0 because there's multiple numbers that will multiply together to get 4. It could be 1 times 4 or 2 times 2. It doesn't guarantee that one of these is equal to 0. So that's why you can't do it. So now you need to basically get the left-hand side ready for factoring. So you can't do any further factoring the way it is right now. So what I'm going to do off to the side here is I'm going to create a box and I'm going to multiply those two binomials. So I multiply the x's, I get x squared. Negative 2x times x gives me negative 2x. 1 times x gives me 1x. Negative 2 times 1 gives me negative 2. Look at your like terms. So now I'm going to take this and I'm going to put it in for x minus 2 times x plus 1. So x squared minus x minus 2, and then I can just carry down this minus 4 equals 0. So now you're going to be able to combine your like terms here because you have two numbers. So we get minus 6 equals 0. And now this looks like something that you'll be able to factor. So we have numbers that add to 1, multiply to negative 6. And again, it's quadratic factoring because there's three terms. This is in the ax squared plus bx plus c form. I don't have a GCF to factor out, so I can go right into quadratic factoring with two sets of parentheses equal to 0. So I split up the x squared as x and x. Negative is what I'm multiplying to, so I'm going to have opposite signs. And I'm going to have to use negative 3 and positive 2 because I need to add to a negative 1. Now that you have two expressions being multiplied to equal 0, this means that one of these would have to equal 0 in order for this to be true. So in order for one of these expressions to, in order for this equation to truly be equal to 0, one of these expressions has to be equal to 0. So you set them both equal to 0, and then we solve for x, so subtract 2 from both sides, we get negative 2. Add 3 to both sides, you get positive 3. So those are your two answers. Either one of them or both of them, if you plug them in, you're going to get 0. So that's why they're solutions. And looking at this next example, we don't have a quadratic. We don't have just an x squared. We actually have a cubic equation. So since this is a degree 3, meaning the highest exponent is 3, this means that we're going to have 3 solutions. So you can't use quadratic factoring because it's an x to the third. So you have to remember one of the other methods we learned in Unit 5. And if you remember, whenever you have 4 terms, you can factor by grouping. So we're going to use factor by grouping. And you always check for GCF first. And I don't have a GCF for this entire equation, but I do have a GCF if I were to split it. So we're going to split it down the middle and factor a GCF out of each piece. So for this first section, I can factor out an x squared. So I do that, I'm left with an x plus 2. And then remember, you're trying to get x plus 2 left when you factor out the GCF. So the GCF is going to be 9, negative 9. So then when I factor out negative 9, I'm going to have an x, and then I'm going to have a plus 2. And remember that these pieces need to be equal so that you can factor that out. So I have an x plus 2, and then I'm left with the x squared minus 9 equals 0. And I'm still left with a quadratic in here. So whenever you have a quadratic left, or an x squared left, that should be a red flag for you to continue factoring. So I'm going to go ahead and I'm going to continue factoring that. So I'm going to keep the x plus 2 because that can't get factored further. But the x squared minus 9, I can use difference of perfect squares to factor that. So you wouldn't have to write the type of factoring that you're using. I'm just doing it so that you remember. So difference of perfect squares means you had 2 terms, you don't have any x term in the middle, and you take the square root of each piece. So I take the square root, I get x minus 3, and then you take the square root and you always have a positive. It's always got to be opposite signs, x minus 3, x plus 3, because the middle terms would have to cancel. So like if you were to multiply these, minus 3x and plus 3x, those have to cancel out to be 0x. That's why they're always opposite signs. And then from here, in order for this entire equation to actually equal 0, one of these 3 pieces has to be equal to 0, or all of them have to be equal to 0, or 2 of them have to be equal to 0, because if you ever want to multiply and get 0, you have to have some of the pieces equaling 0. So I'm going to go ahead and set each piece equal to 0. So then you go ahead and solve it. So subtract 2, you get x equals negative 2. Or add 3, x equals 3. Or subtract 3, you get x equals negative 3. So all 3 of those are going to be my solutions. Again, since it was a degree 3, there should have been 3 solutions. So that's how you know that you've gotten all the correct answers. So one last example to look at is a word problem. So the first thing we're going to do is we're going to look at how to set this up. So it talks about a rectangle, so the length of a rectangle. So as soon as you see some type of shape being described, draw it out. So the length of a rectangle is 4 yards more than twice the width. So I'm going to say let W equal width and L equal length. So if this is my length and this is my width, it says the length is 4 yards more than, so 4 plus twice the width, so 2W. If the area is 70 square yards, so the area of this rectangle, the space inside this rectangle, is 70 yards squared, or squared yards, same thing. Find the width and the length. So we know the equation for area of a rectangle is length times width. And we know these three things over here. So I'm going to go ahead, I'm going to plug them in. So I have 70. My length is 4 plus 2w. And my width is just w. And I need to solve this for my length and my width, but if you look at my equation, it only has w in it. So I'm going to go ahead, I'm going to solve for w. Once I know what the width is, I can plug it into the length equation to figure out the length. So in order to solve this, you need to first set equal to 0 and factor. And there should be two answers because I'm going to see that I'm going to have an x squared. So I'm going to go ahead and first get rid of these parentheses. So you're just going to simplify first. So you get 4w plus 2w squared. I need to set this equal to 0. So I'm going to rewrite this in standard form and set it equal to 0. So I'm going to have it, first let me just rewrite it like this. So 2w plus 4w equals 70. So I just flipped everything because we always want the squared term to be first. And then I'm going to go ahead and bring the 70 over. So bring the 70 over equals 0. And then what you want to do, because you have this number out in front other than 1, look for a GCF. So you need to factor out the GCF first. So don't forget about the GCF. Always worry about a GCF. All those other examples that we didn't have a GCF first. We were able to go right into quadratic factoring or factoring by grouping. So this one, I have a GCF of 2. I can take a 2 out of every piece. Since this is equal to 0, you can just divide everything by the GCF. When we factor, we have to keep the GCF outside of parentheses because there's no equal sign. And you can't change the expression, so you keep it out in front so that if you were to distribute it back through, it would still be equal. But since this isn't an equal sign, it's an equation, as long as you divide one side by 2, and then if you divide the other side by 2, it's still equivalent. So this is the easiest way to do it, is just divide everything by 2. And now from here, we just have our equation that we can go ahead and solve. So we have a quadratic. It's in the form of a quadratic because it's w squared plus 2w plus the number. Or it's in the form ax squared plus bx plus c equals 0. So you're looking for numbers that are going to add to 2 and multiply to negative 35. So we're going to have opposite signs. And our bigger number is going to be positive, our smaller number is going to be negative, so that we add to a positive. And now you can set each piece equal to 0. Since you have a product equaling 0, one of them has to equal 0. So subtract 7, you get w equals negative 7, w equals 5. And since this is talking about width, so if this was just a normal problem that you were just solving for w, you would keep both of these. But since this is a problem where we're talking about a width of a rectangle, we reject this one because we can't have a negative width. So cannot have negative width. It doesn't make sense to say that the width is negative 7. So we keep the 5, and then we're going to go back up here, and this is going to be 5, the width, and now to figure out the length, I'm going to plug in 5. So we have 4 plus 10, so we have 14. So then let's just make sure we actually answer the question. It says, find the width and the length. The units are yards. So the width equals 5 yards. And the length equals 14 yards. And that's it.